3.2, we're going to solve systems algebraically. When we solve our systems algebraically, that means without a calculator, we're going to have two different types of methods. Today we're only going to be talking about the substitution method. So the substitution method is the first method that we're going to be talking about. And we use this method when one or both of the equations already have a letter solved for. So y equals, x equals, either in one of the equations or both of the equations. What we're looking for is to have the letter already solved for. So when we look at x equals 3y minus 1, and we have 4x plus 6y equals 8, the x is solved for. So that's why substitution is the better method. And what we're going to do is we're going to substitute the first equation, whatever x is, into the letter x that it's already solved for into the second equation. So the only thing that's going to replace is the x. We're going to make x 3y minus 1, and we're going to replace it into there. So we do that. So we get 4 times 3y minus 1 plus 6y is 8. And at this point now we only have one letter. And we should be able to easily solve for one letter by distributing, combining like terms, and solving. Well, that's one of our letters. When we solve a system, we always have a coordinate point. A coordinate point has 2 letters. So we only have one of them. We need to find the second one, and we're going to find the second one by taking our y solution and putting it back into our original. And it has to always be original. That'll be more important in the next day than today, but we always substitute into an original. So substitute the answer into one of the original equations. It doesn't matter which original it is. It's just usually easier to go for the one that's already solved for. But you can put it into either one. It doesn't matter. So I'm going to choose the first one because that's the letter that's already solved for. And I'm going to replace the y with what I found. So 3 times 2/3 minus 1. All I did was replace the y with what I found. And I find what my x value is. Now that I know what x is, now that I know what y is, I need to write my solution as an ordered pair. Do not write x equals 1, y equals 2/3. You will get it wrong. It will be marked wrong. You will lose points. When you find solutions, you're finding a coordinate point. A parenthesis, the x, the comma, the y, the parenthesis. It has to be proper notation, proper form, and everything else if you want to get full credit. Okay? So this is where a substitution works out to a coordinate point. Let's look at what happens when that is not the case. Here I have y equals 2x minus 4. And I have negative 6x plus 3y is negative 18. So I want to use the substitution method because y is already solved for. That means I'm going to replace y in the second equation with the 2x minus 4. When I distribute combine like terms, I get negative 12 equals negative 18 because my x's went away. If I get negative 12 equals negative 18, I could get 0 equals negative 6. But no matter what, it's a false statement. It's never going to be true. Negative 12 can never be negative 18. Just like if you were to combine the 12 and the 18, you get 0 as negative 6. That can never happen. If you work this out and you get a false statement, it means they do not intersect. There is no solution. If you were to graph them, the lines would be parallel. Okay, so let's look at another solution or another possibility. Here y is solved for, so I'm going to substitute that into my second equation. When I substitute that into my second equation and replace the y with 3x minus 1, I get to combine all my like terms, distribute, and I get 7 is 7. Or if I were to subtract that over, I get 0 is 0. Either way, this is a true statement. If I have a true statement, I'm going to get all real solutions. That means these two lines, if I were to graph them, they're exactly the same line. I would be graphing one line on top of the other. There would be no separation between them. So again, when we're doing substitution, there are three possible solutions. You can get one coordinate point, you could get no solution because they're parallel lines, or you can get all real solutions because they happen to be the same line. So that's substitution, the first method of solving systems algebraically.